So in this video, we'll introduce various means of two numbers x and y. And x and y are assumed to be positive real numbers. And the first one is the most familiar one to many of us, which is called the arithmetic mean of x and y. Essentially, I'm just taking about the average of the two numbers. So basically, I can just add them up and divide by 2, right? So it is the easiest thing we can do. And for example, if x is 2 and y is 4, the AM is just gonna be 2 plus 4 divided by 2. So the answer is 3, right? So mathematically, it is very clear to all of us. And the next mean, the geometric mean. So some people call it the GM of x and y, and it is basically the square root of the product of x, y. And for example, let's say x is 2 and y is 4. The GM then it's going to be 2 times 4 first, which is 8. Then you take the square root of this, and you can compute it by calculator. It's going to be 2.8 something. So the next mean I would like to introduce is called the harmonic mean. So some people call it the HM of x and y. It is slightly more involved. So essentially, the question I would like to ask is as follows. So basically, the question is we add up the reciprocal of x and y. So it's like you add 1 over x to 1 over y, and you take the average of them. I would like to know what value should it be in the denominator on the right-hand side. So to make this equation equal. And this is what we call by the harmonic mean of x and y. And obviously for us, we can do some algebra to simplify this expression, right? For example, we can use a common denominator on the top of the fraction, right? So now it becomes this equation, and the next step, obviously, we can write it like this. Our HM, which is what we call by the question mark here, is going to be 2xy divided by x plus y, right? So it may be an unnatural formula, but actually it is quite useful in certain application of mathematics. And just as a simple example here, if we talk about x equals 2 and y equals 4, and we can find the HM just by simple numerical computation, right? So you see the HM case is gonna be 2.666 and so on. So the next mean I would like to introduce is called the quadratic mean. And some people use the QM as the short-term notation for the quadratic mean, and the formula I directly give you like this here. And of course, once again, we can use the same example for a numerical computation. For example, let's say x is 2 and y is 4. We can do it as follows. So the answer is going to be 3.1 something. And let's group all we have done together. So now the example we have been using is x equals 2 and y equals 4. And we have looked at 4 different means, right? These are the arithmetic mean, geometric mean, harmonic mean, and quadratic mean. So I list all of these as follows, and the formulas are provided in the blue color. And the particular example is always x equals 2 and y equals 4. And you can see the values, they are different, right? And just from this example, it looks like I can make the conclusion that the quadratic mean is the biggest one. The second biggest one is going to be the arithmetic mean. The next one is going to be the geometric mean. And the last one is actually going to be the harmonic mean, right? And the mathematical question now we can ask is, does this hold true? I'm talking about this whole thing. Does this hold true for any pair of positive real numbers? And I'll give you the inequality as follows. The fact is that for any positive real numbers x and y, we can always form such an inequality, and all these inequalities are going to be equal when x equals y. So let me put it here. So the next thing we are curious about is there any way we can show that it must be true for any positive xy? And I think mathematically it is equivalent to the following inequality, right? So you can take a look at this inequality now, and we would love to prove it one by one. For example, I would like to look at the first inequality on the left-hand side. So let's try to see why this inequality must be true. The first thing to notice is that because both x and y are non-zero and they are positive, so the product of them is still non-zero and positive. So what we can do is we can just do a cross multiplication of the numbers. And obviously x plus y is also positive, right? So if we do a cross multiplication like this, and the next step is we can divide the square root of the product of xy on both ends. So we get something like this, right? And now you see, of course, this term can be cancelled. And you see the left-hand side becomes 2 times the square root of xy. So it means the next step is we're having the current inequality, and then the next step is gonna be this one, right? So it means what? Actually, all of these inequalities on this page, they are all equivalent to each other. So it means that to show that this inequality is true, it is equivalent to showing that this one must be true. And if you take a look at this inequality, this is basically the same as the middle part, right? So it means in order for us to show that the left-hand inequality is true, surprisingly, it is equivalent to the inequality in the middle one. So let's show why the middle inequality is true. And once again, because x and y are both positive real numbers, the product is going to be positive. So it allows us to maybe take a square on both ends like this. And the next step is going to be like this. And can you simplify further? The answer is yes. I can move the 4 on the right hand side to the left, right? And now the next step is, of course, this current inequality is equivalent to this inequality. I hope you can see that, because basically I'm just moving this term to the right hand side. And now you see the current inequality is equivalent to what? It's equivalent to the inequality here, where the left-hand side is the square of x minus y, the right-hand side is 0, right? Can you see why this one must be true? See, we don't care about which value we can get for x minus y, but the fact is because both are real numbers, this one is a real number, right? So for any real number to the square, we know that it must be non-negative, right? And because it is always non-negative, we understand that this one must be true all time. Yeah, for any real number x and y. So it means what? It means equivalently, if you come back to the top, this inequality must be true, right? And after showing that this inequality must be true, it basically means the inequality now in the black box is always true, because we mentioned it already. The inequality in the black is actually equivalent to the inequality in the purple. And I think now there's one more inequality to deal with, which is the one in the red part, right? And let's try to prove why it must be true. So to prove that this inequality is true, we have to understand that, I mean, all of these numbers that we look at on the left side and the right side, they must be positive, because x is non-zero positive number and y is also a positive non-zero real number. So it means we can take the square on both ends. And then the next step is gonna be the current inequality after squaring both ends, right? And now we can move the terms around. For example, the 4 can be pushed to the right hand side to get the current inequality. And of course, we can write the right hand side as 2x squared plus 2y squared, right? And then we can move all the terms on the left hand side to the right hand side. So after that, we are getting this inequality. And this inequality is something we have looked at. This is essentially saying that the square of x minus y is always non-negative. And we already explained about it. This one must be true all the time, right? Because x minus y is certain real number, it can be negative, we don't care. When you take a square of any real number, it always is non-negative, right? So that's the end of the proof of the inequality we look at up in the black box here. So I think we basically finished the proofs of all the inequalities back into the original mathematical inequality we look at, which is this one. So the conclusion here is that this one is always true for any positive real number x and y. And that's the end of this video.